Alright, so in this video I'm going to talk about the hyperbola and we're going to sketch them. We're also going to take a look at the general equation and how that relates to how the equation looks. Alright, so first of all, a very, very simple hyperbola. The simplest you can get is y equals 1 over x. Now, if I sketch y equals 1 over x, what I'll get, here's my Cartesian plane, x-axis, y-axis, arrows everywhere you want them, and then an equation that looks like this. Now, a few things to note. It's symmetrical around this axis. Okay, so it's symmetry. Also, this line is getting closer and closer and closer and closer to the x-axis, but never quite touching it. Okay. And this line is getting closer and closer and closer to the y-axis, but never quite touching it. Now, a line that an equation is approaching and getting closer and closer and closer and closer to, but not quite touching, is called an asymptote. Now, in this case, we have a horizontal asymptote of x equals 0, and we have a vertical asymptote of y equals 0. Finally, it's probably worth noting that if I subbed in the number 1 here for x, 1 over 1 is equal to 1. So we do have a point that we can sort of reference over here. When x equals 1, y equals 1. It's an interesting point on our asymptote. Alright, that's the most simple version. Similar, y equals x squared is the most simple parabola. Y equals 1 on x is the most simple hyperbola. Take some notes, then we're going to move on. Here's our basic form of a hyperbola. Y equals a over x minus h plus k. Now you'll remember that the simplest form was y equals 1 on x. So all we've done is subtract something from the x, add something to the fraction itself, but then also multiply the fraction by something up the top. That's our a value. And a, h, and k are all going to affect our equation. Probably the easiest way to explain this is to explain it in terms of the quadratic, which you already know. So the quadratic equation is y equals a x minus h squared plus k. And you should know a few things about that. You should know that h and k will affect the turning point, sort of the middle point of our quadratic. Similarly, h and k are going to affect the middle point of our hyperbola. So, if my original hyperbola had asymptotes at x equals 0 and y equals 0, and my original quadratic has a turning point at 0, 0, think about what the h value does for our quadratic. It shifts it left and right. The k value shifts our quadratic up and down. The h values and the k values are going to shift our hyperbola left and right. I'm just going to leave that aside for a second. The a value changes how squashed up our parabola is. So if you've got a high a value here, it's going to look like this. If you have like a fractional a value, like a half, it's going to look like this. And if you have a negative a value, it's going to flip. Oops, it's going to flip your quadratic upside down. Similarly here, an a value is going to stretch that hyperbola up. A fractional a value is going to squash that a value down. And a negative a value, remember our first hyperbola looks like that. If you've got a negative a value, it's going to flip everything, and our hyperbola is going to move and look like that. That's a negative a value. Alright, I'm talking pretty quick and I'm sort of sketching about stuff because we're going to do this in greater depth in a minute. Just a few little notes for you to write down about what a, h, and k do. Now I'm going to jump to an example. I'm going to sketch y equals 2 on x minus 3 plus 4. So here's my Cartesian plane. Use a different colour. Now, think about what the h value does. A h value of -3 is going to move it left or right. And the h value always behaves kind of the way that you think it won't. So the -3 isn't going to move it to the left. The -3 is going to move it to the right. So I have an asymptote, which I show with a dotted line, a vertical asymptote, and the equation of my vertical asymptote is x equals 3. Okay, and then I have a +4. Now that +4 is going to move the way you'd expect. The k value moves things up. So I'm going to have a dotted line about there. There you go. So there are my asymptotes, the things that the equation is going to get very, very close to but not touch. The a value. Now the a value is positive. That means it's going to be a positive hyperbola. So there's going to be a curve in this quadrant and a curve in this quadrant, what we call quadrant 1 and 3. That's 1, 2, 3, and 4. Okay, and finally, it's probably worth sketching, when we sketch this, you can see that it's going to pass through the y-axis and the x-axis. And most hyperbolas pass through the x and the y-axis, as long as the x and the y-axis aren't your asymptotes. So, to find x-intercepts and y-intercepts is very, very simple. Find the x-intercept, let y equals 0. Find the y-intercept, let x equals 0. So, let's do it. Find x-intercept, let y equal 0. So 0 equals 2 on x minus 3 plus 4. 4 comes over here, -4, 2 on x minus 3. I can move that x minus 3 up to here, so it'll be -4 times x minus 3 equals 2. Now, I could expand those brackets. Yeah, let's do that. -4x plus 12 equals 2, which means that if I move that 4x over to here, I'll have 4x equals 12 minus 2, x equals 10 over 4, which is 2.5. Okay, so the x value here, that's our, let y equal 0, that's our x-intercept. That's going to be 10 over 4, which is 5 over 2, which is 2.5. And that bit's 3. Okay, and then find the y-intercept. Let x equals 0. I think this one's going to be easier. Y equals 2 over 0 minus 3 plus 4. 2 over -3 plus 4. 2 over -3 plus 4. I'll do this the slow way, I guess. I'll make the denominators the same. -12. That's right. Okay. 2 plus -12 is -10. -3, -3. So that's positive 10 over 3, which is 3 1/3. Just write 10 over 3. Okay, that's really it. I have my asymptotes. I have two x and a y-intercept. And now I just draw them so that... And then remember, it's going to be symmetrical around this 45-degree angle. So I just try to draw something that looks symmetrical both ways. I haven't done a very good job there. Must be because I have to work over my working. That's terrible. Alright, it looks closer. It's not quite right, but you get the basic idea. Alright, that's the equation of a hyperbola. I've sketched a hyperbola there. Find the asymptotes, find the x-intercept, find the y-intercept. That's it.